Let's take a look now then at these 14 floors above the damage where the plane came in as a block in the North Tower. And let's do two things. Let's have a giant crane and imagine that picks up 14 floors and just drops them in air. You know, no building below, just drop them in air. How long will it take for the roof to get to the ground when you do that? Well, it works out to just about 9 or 10 seconds. There's some air resistance, but pretty much ignore that. The height of the North Tower, 1,368 feet. If you dropped a steel ball in vacuum, it would drop in 9.2 seconds. So we got this big block. We're doing the same thing, except we're dropping it in air. And, 9 or 10 seconds is what you'd expect. Now, how long did it actually take the building to collapse? Well, it was about 10 seconds, maybe 12. It's a little hard to tell now because there's so much dust, but if you look at the seismic record, when the shaking started, as that building started coming down, when it ends, just about 10 seconds. Okay, now we've done that one experiment. We drop it in air, 10 seconds. Now you take the same block and you drop it over the rest of the tower that's still there. You've got 47 core columns below, 240, these are steel columns going up the center of that thing, huge. At the base they're 4 foot by 2 foot, steel. Okay, interconnected columns, designed to stay standing, not to just give up, when something hits them. And then you've got 240 perimeter columns. Now you drop that block of 14 stories, okay, above the damage zone. You drop that drop on the rest of the building. What happens? Well, which is going to take longer? The one you drop in air or the one you drop on, a couple 100,000 tons of steel and concrete that's designed to remain standing? Which is going to take longer? The one that you drop on the building obviously should take a lot longer than the one you just drop in air. The situation, when you time it, it's essentially free fall speed. Goodness, how does that happen with all this steel in the way?
The entire building has just collapsed, as if a demolition team set off. When you see the old demolitions of these old buildings,
it looks like one of those scenes of an old building being, purposely dynamited and blown up.
I spoke to the chief of safety for the New York City Fire Department. He received word of the possibility of a secondary device, that is another bomb going off. He thinks that there were actually devices that were planted in the building.
If you wish to bring anybody who's ever watched a building being demolished on purpose knows that if you're going to do this, you have to get at the under infrastructure of a building and bring it down.
This was clearly the way the structure is collapsing. This was the result of something that was planned. It's not accidental that the first tower just happened to collapse and then the second tower just happened to collapse in exactly the same way. How they accomplished this, we don't know.
There's another way of saying that we need to look at conservation of energy and momentum. That analysis has been done by Professor Cutler, professor of mathematics. He comes up with 36 to 40 seconds, just this block hitting stationary matter. And now you throw in the columns, and this gets us to Gordon Ross, a mechanical engineer in the United Kingdom. He says you put in the columns and conservation of energy and conservation of momentum. None of those looked at by FEMA and NIST, you see this. His final result is that the upper block will stop. The destruction goes a ways, but then it stops. I mean, why should we assume that the building below just gives up? No. That upper block goes a ways and then it stops. And it might actually fall off due to asymmetry. That's what you expect. You don't expect it to fall straight down at free fall, near free fall speed, unless you get the material out of the way below. The way that's done is with explosives.